know these three. You actually know all of the rules, but you don't remember the two that are at the bottom of the page perfectly yet. So, product rule. If you have two things with the same base being multiplied, what do you do with their exponents? You add. So this becomes x to the fifth. Quotient rule. If you have two things with the same base being divided, what do you do with their exponents? So you subtract them. And it's top minus bottom. So 6 minus 4 is x squared. And the power rule, when you have a power to another power, what do? You multiply. So x to the 10th. All right. So Miss Newman's an evil genius and came up with algebraic ways to represent this. Well, isn't that nice? So we're going to do number 1. You have two things with a base of 2 being multiplied. What should you do with their exponents? Add them. So 2 to the what? 4x plus 10. Good. Take 15 seconds and do number 2. Same base, so you add their exponents. Yes? E to the x squared minus 5x? Good. Okay. Number 3. 10 to the x raised to another 3x. What do you do with the exponents? What rule is it? Yep, you multiply. So what does that become? 3x squared. Good. All right. So again, take 15 seconds and do number 4. Power to a power, you multiply. So you should have 7x squared plus what? 14x. Good. All right. Number 6, I'll let you do number 5. Number 6 is a complicated looking one, isn't it? What do we do with the exponents? Subtract. And so it's 10 x squared plus 5x minus 1 minus the whole bottom exponent. Now, why am I being so drama about the whole bottom exponent? You've got to distribute that negative. Oy. So, ready? I'm going to do this in my brain. X squared minus x squared. They cancel. Okay. 5x minus negative 3x. What's the double negative? Positive. So what is it? 8x. Negative 1 minus 2. Negative 3. Good. Now, you do 5. Take 5 seconds and do 5. E to the negative 2x. Negative exponents. I told you about those before, didn't I? What does it mean? If it's in the, do what? So move it to the bottom of the fraction. Mr. Newman, it's not a fraction. Well, isn't it an invisible fraction over 1? So move it to the bottom. So 1 over e, and then you make it to the positive 2x. So, I did teach you that before. Negative exponent rule. You move it to the bottom and make it positive. Move top to bottom. What if it's negative and it's in the bottom? What do you think? Or bottom to top. Okay. Now, the fraction rule. You never taught us this. You sit on a throne of lies. Back in Unit 2, I told you about this. I said square root means to the 1/2 power, right? Cube root means to the 1/3 power. So if you have a rational exponent, a over b, yes, we saw that whole shenanigans. And I even had you practice writing it at some point. I don't remember when. So, the rule that I told you at the time is it's the b root of x to the a power. And the phrase I told you was power in the sky roots in the ground. So, there we go. So the sun gives the tree its power, so that's the numerator, and the roots are in the ground, so it's the denominator. Get it? Power in the sky, roots in the ground. Look how happy I am in that tree. There's a bird and some butterflies. Okay, so we're going to practice this. I'm going to do the odds, you're going to do the evens. So I'm going to say, we're going to go through this together, and then you're going to go back and do some ones by yourself. Are you ready? Should I use sticks? Yes. Okay, good. 2 to the negative 1. Negative exponent means what? Fraction. So where should I move the 2? To the bottom, and it becomes positive. Do I have to write 2 to the positive 1? No, that looks weird. All right, you're going to do 8 in a minute. 9. What do we do with exponents? Both e. What do we do with the exponents? Subtract. That's e to the negative 1 minus negative 2. Negative 1 minus negative 2 is positive 1. Yes? It's over. You'll do 10. Let me show you 11. Now, this is a big deal. So, we've got two separate things going on here. We've got two pieces. See that? Two piece. What has the negative exponent? 4, e, or both? Just the e. So what moves to the bottom of the fraction? Just the e. So 4 stays put, e goes to the bottom. Minus e to the negative 2. How should you write that? E squared on the bottom. What lives on the top then? A 1. Nobody likes 12. 13. X to the 1/2. You're just going to rewrite it with the root and the power. So, power in the sky, x to the first, roots in the ground, square root. You'll do 14. 15. Power in the sky, y cubed. Root in the ground, 4th root. Good. We've done this before. 17. How should I write that? 10 to what exponent? 4. And what root do I put on my, what index do I put on my root? 3. Okay. 19. Ooh, Miss Newman got fancy. It's a negative and a fraction. Oh my gosh. First of all, deal with the fact that it's negative. Nobody likes a negative Nancy. Where should that be written? In the bottom of a fraction. X to the positive 1/2. Okay. Now change it to 1 over, what's the exponent on the x? 1. What's the index on the square root? 2. Sorry, I said square root. I didn't mean to. All right. Now, 21. Look at it. Spy on it. What do you think you need to be careful of? Who has the fractional exponent? Who has the exponent? Is the 5 involved? No, he's like, he's just watching the show, okay? So when I go to do this, I'm not going to lose my parentheses on x plus 1 because what exponent is on them? What's the power? 3. What's the index? 2. So what the heck do I do with the 5? He just lives here. That's it. Okay? Okay, take a few minutes and do the ones we see. All right. 10 to the negative 2, what do you do with it? Bring it up. Becomes 10 squared. What's 10 squared? 100. Nailed it. All right, number 10. This 3 is living its own life. It's living its best life by itself. Nobody cares what this guy's doing. 3 is on his own. So how did you write 2 to the negative 3? 1 over 2 cubed. What is 2 cubed? Yes? Okay. You could calculate that. I'm not going to worry about it right now. 14. How do we write that? What's the power? 1. What's the index on the root? 3. 16. What's the power? What's the index on the root? 18. What's the power? What's the index on the root? You sound like you're so bored. Life is so easy. Let's be careful here. What has an exponent? So does 2 go anywhere? No, he's going to stay in the top. He's like, see ya, X. They broke up. Now, how do I probably want you to write that? Cube root of X. Cool? Now, can you always check that you rewrote this properly? If you store a value with the original and then the way you wrote it, see that they're the same? Always pick a weird number, though. Otherwise, if strange things happen. Okay? So, now that we know all the rules, we also have to be able to explain what the heck is going on. When you're explaining this whole scenario, what I feel like you're happiest with is almost like a proof setup, if possible, where you do something and then you say what rule you applied. You do something, the rule, you do something, the rule, right? That's how you were trained in geometry. So it says explain how this can be written as the equivalent radical expression. Okay. Well, they're telling us they're equivalent. So I'm going to say, all right, well, 4 to the 1/6 squared is equal to the cube root of 4. That was given to us. Which side should you change? The left, always the more complicated side, right? So what rule do we apply first on the left-hand side? What do you do with the exponents here? Multiply. So that's 4 to the what? What's 1/6 times 2? 1/3. 2/6, which is 1/3. And what did we do? We multiplied exponents. Okay. Now what do you do? Fractional exponent. What phrase do you know? So 4 to what exponent? 1. What do I put around it? Cube root. Now, you can actually write power in the sky, root in the ground. Does that make it easy to do it that way? With like just say what you did, with a program here? Sometimes some of you will start writing sentences, and you'll get most of it, but not all of it. Or you'll start talking yourself into a circle. Ever do that? And then you look back at your work 3 days later and you're like, what was I talking about? I also want to know what you were talking about. So this makes it like a little bit more clear. Just tell me what you're doing. So do the same thing in 23. Do this one on your own. What's the next thing you wrote? 27 to the 4th, and then cube root. And what did you say? Power in the sky, root in the ground. Okay. Then what? So you did... Okay, so you did this. What is that? Yeah? I mean, really, right? And then 81 equals 81. And I would just say evaluate. You've already told me what you knew about exponents at that point in time. So let's go to some more complicated looking ones. Number 24. Does that look scary? Heck yeah, that looks scary, right? It says, use the properties of rational exponents to determine the value of y for the equation. Does it say to explain? No, so we're good. What would you do first when you look at that? It's up to you. There's 2 different things you could do. It's up to you. Okay, so you want to do what with that? Change it into what? Oh, okay, so let's see here. What we actually want to do is we prefer the fractional exponents. So I'm actually just going to say, let's deal with that by multiplying them so that it's x to the 3 over 4. What should we do in the numerator? So put it x to the what power? 6 over 4. But Miss Newman, isn't that? Yes, it is, but wait for it. What are you going to do with them now? Subtract them. 6 over 4 minus 3 over 4 is 3 over 4. The question asks you to determine the value of y. What's y equal to? 3/4. This is the only time I allow the diagonal fractions. Yeah? Okay. So 25 is sort of similar. Why don't you guys do 26 and, well, let me look at the time. That's a lie. Don't do 26 and 27. We're going to do 25 real quick. All right, so given the equal terms, x square root of x cubed and y to the 3/4, determine and state y in terms of x. Huh? Did you read that and go, huh? Yeah. Equal terms, what should you do? Set them equal. Oh, there's a novel idea. Now again, some of you have handwriting that you need to change your font size. You can't use size 18 font the whole time with exponents and the regular level. So what should we do first? Okay, so change the x. What would that look like then? To the 3 is the power. What's the root? Over 2. If it's not written there, it's a square root, right? That's the understood number. And then y to the 3/4. Okay. Now it wants us to state y, meaning get y alone in terms of x. Oh. How do we get rid of an exponent of 3/4? We did this in Unit 2, but it's been a long time, right? It was like October, early October. So let me remind you. In order to get rid of a fractional exponent, you raise it to the reciprocal. Why? Let me show you again. We'll do it here. If we use, what's the reciprocal of 3/4? 4/3. And what's the rule of power to a power? You multiply, right? 3/4 times 4/3 makes what? 1. So that'll be a 1. We have to do the same thing over here. What's 3 over 2 times 4 over 3? 12 over 6, so 2. Did we get y in terms of x? We did a beautiful job. Cool? All right. I like this one for oh so many reasons. It wants us to express this fraction in simplest radical form. Wow. Yikes, yeah? What has a 1/3 exponent? Everything in those parentheses, true? So 27 to the 1/3, x cubed to the 1/3, y to the 6 to the 1/3. So ask your calculator right now, what is 27 to the 1/3 power? what does it tell you? 3. What do you do with the exponents here? X cubed to the 1/3. What do you do with those numbers? Multiply. What's 3 times 1/3? 1. Y to the 6th to the 1/3? 2. By the way, I'm going to get rid of these directions. They don't make sense for what it turns out to be. What would you do next? Even before that. Yeah, those 3s. Done. Gone. Okay, so then everybody's like, subtract. Subtract, Miss Newman. Yeah. So what is 5/2 minus 1? 3/2. And it's positive, so it stays on the top. And the y squared can stay on the bottom. Yeah? You could rewrite the top as the square root of x cubed over y squared, but we're not going to. Okay, so next thing. Now again, I took these questions, I probably copied and pasted straight out of Unit 2. We did this before, but it's a good time for a reminder. Agree? Cool? So, I'm going to go over here. I'm going to do the odds. The directions say, get the weird thing alone, meaning the thing with the weird exponent. Undo the weird thing. How do we undo a fractional exponent? What do we use? So I want you to say the words raise to reciprocal power. What a lot of you will say is, you multiply. False. You don't multiply by the reciprocal. You raise to the reciprocal power, and because you're doing power to a power, you multiply the exponents, right? But what you mean and what you say have to be the same thing. So, x to the 1/3 equals 4. Is the weird thing alone? Yes. So we're going to undo the weird thing by raising to what exponent? 3/1 or 3. We raise to the 3rd power, which gives us 1/3 times 3 and the exponent, which is an exponent of 1. You're supposed to check these. Really, it's any that have a denominator of 2 that you have to check, because they're square root equations and you have to check square root equations. But the likelihood of you remembering that is low, so I say check all of them. Yeah? Okay. Check. All right, 33. What do we do first? If you have to get the weird thing alone, add 1. So x plus 2 is in parentheses. 3/4 equals 8. I usually give myself a little more room than I just did. Okay, undo the weird thing. So what reciprocal power are we raising to? 4/3. Okay. Now, we're multiplying the exponents, which gets us 12/12, which is 1. So x plus 2 equals 8 to the 4/3, 16. By the way, cube root of 8 is 2. 2 to the 4th is 16. For those of you that get it, it's a nice little thing to be able to do. Solve for x. So type it in, see that it works. So go to your calculator, in parentheses, 14 plus 2, raised to the 3/4, minus 1. Make sure you arrow out of the exponent when you do the minus 1. Make sure it says 7. Does it check? Okay. 35. Get the weird thing alone. What do I mean by that? Divide by -2. So x to the 3/4 is equal to +8. Did we just have that situation a minute ago? Close. It's hard to pick numbers that work out nicely. Okay. Undo the weird thing. What do we need? Reciprocal exponent of what? 4/3. These two things get multiplied and make 1. And 8 to the 4/3 is 16. So check it in your calculator. -2, parentheses 16 to the 3/4. Does it check? Ding, 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 ding. Yeah? Okay. Last one here. You tell me what to do. Go. I'm your little robot. Subtract 3. Beautiful. Now what? Raise. Do you see how easy it is to say that? Like you want to say it, but you know you're not supposed to. Raise to the reciprocal. Beautiful. So they multiply to be 1, so x plus 2 equals, square root of 4 is 2, 2 cubed is 8. What's x equal? 6. Okay, I'm going to tell you it checks. And what do you think you're going to do right now, real quick? Let's see. I'm going to pick 2 instead. I'm going to pick 32 and 34. Do those two. 32 is 25. Good. What do you get for 34? Do you feel like a genius? Yeah? Okay. So, notice